Hello everyone. I want to do a video on just how to remember certain formulas. So there's a lot of formulas that you have to know in trig, and so people always ask me, how do you remember all of them? And the truth is I don't. I remember a few, right? So I remember sine squared plus cosine squared is equal to 1. You learn this fairly quickly in trig, right? But this is called a Pythagorean identity, so maybe I'll write that up here. And there's 3 that you need to remember from trig onward, right? So going forward, you need to remember those. So how do I get the second one? And all I do for the second one is I remember the first one. So the first one is sine squared plus cosine squared x is equal to 1. And if we divide everything by sine squared, what do I have? Well, I have sine squared divided by itself, so just 1. Cosine squared divided by sine squared, that's cotangent squared. 1 divided by sine squared, that's just cosecant squared. So that's the second Pythagorean identity. And then what about the third one? So the third one, let's do that one in pink. So again, I just remember the first one, sine squared plus cosine squared is equal to 1. And then if I divide everything, last time we did it by sine squared. This time let's divide everything by cosine squared. So I have sine squared divided by cosine squared. That's just tangent squared. Cosine squared divided by itself, that's 1. 1 divided by cosine squared, that's just secant squared. And so there's all 3 of your Pythagorean identities. And the other 2 I got just from remembering the first one, right? Sine squared plus cosine squared is equal to 1. So that's one set of equations. And let's do a few more. I don't think it'll take too long, and they're usually they're straightforward. I mean, once you see them one time, I think it's easier to remember the formula, and you can always go back and just rederive it, like we derived those number 2 and number 3. So another equation you'll see in trig is a power reduction formula. So cosine squared is equal to 1 plus the cosine of 2x divided by 2. So this is our power reduction. Power reduction in half angle. So this would be our first one. This is the one I remember. Just like I remembered sine squared plus cosine squared is equal to 1, I remember this equation. Once you remember this equation, how do you get sine squared? And the way I remember that is, it's just like cosine squared. Everything's almost exactly the same, except there's a negative here. So remembering that, now we need to come up with what's called a half angle. So what if instead of putting in, let's say I put in, so here I put in an x, if I put in an x over 2. So I'm going to get the cosine of x over 2 and then square that result. So let's plug it in here. 1 plus the cosine of 2 times, so instead of x, we're plugging in x over 2, right? And this is all divided by 2. Well, 2 divided by 2 is just 1, right? So this is 1 plus the cosine of x divided by 2. And we're almost done. Typically for the half angle, we want to get rid of this squared. We want just the cosine of x over 2. So how do I get rid of it? If something's squared, I square root both sides. So if I square root this side, this 2 goes away, right? Square rooting this other side, then I have to do plus or minus, right? So then we know that the cosine of x over 2 is equal to plus or minus the square root of 1 plus the cosine of x. So that's our half angle formula for cosine. And then for sine, we go through the exact same thing. Here it's just 1 minus cosine, right? But we're going to plug in x over 2. 2 divided by 2 is just 1. And we square rooted both sides. So that's how I remember the power reduction and half angle formulas. I remember this one formula. From that, I derived the other 3. And the only thing you have to know, other than just that cosine squared of x is equal to 1 plus cosine of 2x over 2, is that sine squared is nearly identical. There's just a minus here. And then you can derive the rest. So I hope that was helpful. I'm going to try to do a few more of these videos, and that should make it easier just to remember a lot of the equations that you see in trig. Thanks.